Okay, so what we're up to now is we've done a fair bit looking at these scatter plots. We've done, now we just did yesterday finding the equation. So what they now say is we're going to perform a regression analysis. So it means when we get a set of data and we're going to go through the whole process of doing everything. So what would happen is we'd first get our two lists of data, and we would decide which one is our EV and our explanatory variable and which one is our response. We'd construct a scatter plot, so we've done all this. We then comment on we say the R, the strength, and then we looked at yesterday getting the equation, so where we would write out the equation using our variables, and we looked at where we found them on our calculator. So then we had, with the next thing in our regression analysis is we're going to look at interpreting those the coefficients. So really what it means is explaining what the A and what the B value tell us when we write that out. Okay, so as I said, when we have anything that's interpreting, I would have a fill in the blank statement for you, so you don't have to stress about whether you're writing it correctly. So we'll look at that. And then once we have this equation, the next thing we'll do is we'll make predictions. So we've got the data, we've got a formula that tells us. So we're going to use this formula because, you know, someone might say, oh, well, what do you think will happen if the EV was this? So we'll use our formula, and that's called making a prediction. So we'll do them. We have already looked at the R squared, and we also how to interpret that. So that will come up again. And then we have to remember when we've done all these linear regression lines, so when we've done the equation, we always made the assumption that it was following a linear pattern. So this residual plot is, you might want to write, is the test for if it's actually linear, the data, yeah? Linear. So meaning, is it really linear? And this residual plot is a test for that. And I'll show you how to do it. Then they say we're going to write a whole report. It just means you'll write dot points, but you never write a whole report in your exam. You just do those individual interpreting, and I'm pretty sure the stack's pretty similar too, but I'll show you how to do it anyway. All right, so we're going to have a look at this example here. So we have the life expectancy in years and birth rates, the number of births per 1,000 people for 10 countries. All right, so what I want you to do is we're going to go pop this in our calculators. So I'm just going to, all right, so we've popped in lists and spreadsheets, we put in our list. Yeah, we put it in our list, and then we went to data and we created our scatter plot. Okay, and then we went in and we found this equation, and we found that in our list of statistics. So we found our A value and our B value, and we wrote it out with our variables. Okay, so let's go to the next bit. So here, I'm just gonna write out our example here on the side. So our equation was life expectancy equaled, and I'll write our A value was 105.4 minus 1.4. I'm just gonna do 2 decimal places, 4 times birth rate. Okay, this is just so we can refer to it. All right, so here is what you have to do if you need to interpret any of the values. So if they say interpret the slope, which is the B value, so you can see there, slope, B value. What we're going to do is you have to choose. It's either this one or this one. So we're looking at it in my example here. Do I have a negative B value or a positive? I have a negative. Good. So I'm going to write this statement will be the one I use. So for this example, I would write now, see in yellow it says RV. So I'd write the life expectancy, because that's what RV is, decreases, and I'm saying decreases because B is negative, by, now it says there you have to put the B value and the RV units. So the B value is 1.44. I don't need to write negative because that's what the word decrease means. So life expectancy decreases by 1.44. Now what was the life expectancy units? What were we measuring it in? It was years, so that's why that says RV units. Okay, now we have to say the EV, which is birth rate. So when the birth rate, you can say per thousand in bracket, increases, so this one, you always write increases, by 1. Now what was, we say 1, so 1 birth or whatever. You can just say Y1 in this one because it's sort of weird, but that's all right. If you wrote that statement, that would. So can you see how these were the bits I just had to change? Yeah? So you just have to do it every time, write this little statement, and you're going to get the mark. So in an exam, that would be 1 mark to interpret that. There's 1 mark. 1 mark in an exam is big in further, it really is. So there's 1, done, sweet, easy. And in your stack, it could possibly be a little bit more. So we've interpreted the slope. So obviously I've got both options there in your notes in case it was positive. Now the next thing is they want you to interpret the intercept, which is the A value. So that would be up here. So off I go, I'm going to interpret that. And so I would say the same. I'd say the regression, so they're actually written down here, so I'll do it here. So the regression line intercept predicts now I had to put the RV, so that's where I've said life expectancy for countries to be now, I'm going to write it, this one's a little bit different, so I'll write it the way we would do. So we'll say the regression line intercept predicts the life expectancy, so that's what my RV is, to be 105.4 years when the birth rate is 0 units, okay? So that's just simply means if there was a country not having any more birth, like none of their people were having births, they're saying that those people would live to 105. That's what it's saying, okay? So we saw it's negative. The higher the birth rate, the less likely the life expectancy is decreasing. So it sort of makes sense. If you think of heavily populated countries, like, so you've got like India and China and that, their life expectancies aren't as much. So then you might investigate why that is. We're just saying we're just saying there's a correlation. We're not saying it causes it. Okay, so then we move on. We've done all our interpreting. Then they say we get asked to make predictions. So we can see in our example here, here is our equation, and they asked us what would the life expectancy be if the birth rate was 35. So you can see here's the A and here's the B. So they've popped in that X value or the birth rate of 35, and we get 55 years. That's the life expectancy, okay? And then, so you can write a statement, but generally they just say, what do you expect? And you do the prediction. So just gonna grab the scatter plot for a minute. So we could be asked to predict any value. So it could be, we could ask, what if the birth rate was 60, and you pop that in. So what you then have to say, they'll then might ask you, what are you predicting? Are these reliable or not? So if you're predicting within the range of data, so what does that mean? So can you see in this example, one of our lowest birth rates was actually 25. So this was our lowest country birth rate. And our highest birth rate was like 45 or whatever, so the highest birth rate. So if you're predicting within here, in between the dots, in between the scatters, if you're predicting, that's called interpolation. And we like to call that reliable. Why do we say it's reliable? Because we have seen the countries around that. We've got actual data around those birth rates, and we have actually seen what happens. If we predict out here, so if I predict less than that, so anything less, or if I predict anything more, that's called extrapolation, and that's not really reliable. So because what would happen is sometimes the trend might completely change after that little section. Something could, happen. So you need to let people know, yes, we're predicting, but this is not where we've looked at data. So we are predicting, so we say it's extrapolation, it's outside the range, and it's not reliable. So you might want to highlight that the prediction is not reliable. So, or maybe just write that, because they'll ask the question, why is this not reliable? And you will have to say, because it's extrapolation, you're predicting out. Or they might say, make this prediction, what is it, interpolating or extrapolating? So you'll have to state that, which one it is. Okay, so if we look up at this 35, what was 35? Were we interpolating or extrapolating? We were interpolating for this one. So this one was fairly reliable. Okay, so then our next bit would be interpreting the coefficient of determination. We've already done that. So in this example, you can see it says the coefficient of tells us that. Now we had an R squared value of 0.651, so we changed that to a percentage to 65. So you can say, we would say that coefficient of determination tells us that 65.1% of the variation, and we would say in life expectancy, would go in there. It can be explained by the variation in, and we'd write birth rates. You guys are used to that. You've already done some practice on that. That one's easy. So we would say 65% is fairly strong, isn't it? It's pretty high. So we're going to say, yes, when we see a change, so when we see this birth rate moving up and down, we see this life expectancy changing, 65% of it. So when we change it, we see 65% of change in that. So that's fairly high. We would say there's a correlation, yeah? And we already said there's a strong correlation. So we might go investigate why that is with other things. So you'd look in your other sciences and that. So maybe, you look into why, is medical, facilities the same when there's high populations, who knows, and you go into all of that. Then we know, because it's 65%, we can say, and I've just said, if it's under 30, we sort of say it's not worth it. All right, now this is the last bit, which I'll go back to our calculator in a minute. This is the test to see if it's linear, okay? And it's the residual plot. So really important here, a key assumption, so we assumed all this data was linear we assumed it was when we found the R squared, and the equation. We assumed it was following this straight line path. So now we're going to do a residual, will show whether it is or isn't linear, whether it's not following. So what's a residual plot? So remember when we talked about when we had the scatter plot, and we then had our line of best fit. So remember we said the residuals were the difference there. Yeah, these would be a positive residual, these would be a negative because the actuals are less than. All right, so what a residual plot is when it actually, what it's going to do is you're going to have all your little x values along here, and what you'll graph along here are the residual amounts. Okay, so if you think about it, if your dot was right on the line, it would have, what type of residual would it have? The actual minus the predicted. If it's the same number, what will it be? It'll be 0. So you'd see, what you see in the residual plot along here, you have this 0 line. So just say for this, my little example up here, this first residual up here would be a positive. So it might be there. This one's a little bit closer to the line, so it might be there, and so on, you know. And so you end up with a residual plot, something like that, yeah? Sorry. Yeah, and so that's what a residual plot. Now the calculator does this for us. You know, we don't have to go calculate every individual residual, but you do need to understand that's what's happening. So let's go do it on our calc. Okay, so just here, they have asked us to find a few individual residuals. So it says the country labelled A on the scatter plot has a birth rate of 34. So and a life expectancy of 60 years. That becomes the actual, that's actually what happened. So when it says calculate the residual, you'd have to use the formula, which they did. We found up 34 years, we found it to be predicted. Here's the predicted. And so when they found an individual residual, they just did actual minus predicted, and that's it. So that's what they found. So you may get asked to find some few little individual ones, and you just follow that little formula. But obviously we just went through this, but here's how we get the residual plot. So this is on our scatter plot page. You might just want to write that, which is our data and statistic page. And here there, it's telling you how to get it. You might just want to make a note. You must have the regression line on there. Have regression line. You won't even be able to get the residual plot unless it's there. So you must have the regression line on your scatter plot. Okay, so just write a little note there because it sort of hasn't really said it there. So this is just the calculator instructions here. So this was not our example. This was another example. Now, can you see in here, can you see that residual plot? See how it looks like a pattern? Yes? So if you want to write next to this, write the residual plot. This one shows a pattern. Therefore, the original data is non-linear. Okay? Here, down here, this one, this residual plot, and that was the one we just did with our example, we would say the residual plot shows you can say a random scatter, or you can say no clear pattern. Therefore, supports assumption that original data was linear. Okay, so that's what you have to remember.